Hey guys, welcome back to this lesson. So in this chapter 3, we'll be looking at UX design for agentic system. In any software or you are designing, you must put your users into congregation or into consideration. You must make your platform accessible and catchy to your user. You must make sure that your platform or your user interface is easy to navigate for your user. It's easy to manage for your user. You must put all your tools, all your tabs in appropriate places, in a place that is visible to the users, so that the user can easily navigate or your user environment. So we'll be looking at that in terms of coding and theoretically here, but we'll not actually be designing user interface. That will be I'm going to stream a real life agent where we'll build an example of an agent together, and then we'll see the user interface and how to interact with the user interface. So user-centered evaluation, you must make sure you design a system that is user-centered, because what's the point of designing a system when the user cannot use it, or when the user cannot navigate the system to get what they want? So the system will be useless. So you must put your users into consideration when you are designing a system. So technical success, as you know, is not equal to user success, because or you can design a system and be happy with it, that you've achieved a milestone, or you've solved a big problem, and your user may not see it as a big problem. Your user might have problem with it. If your user have problem with using your system, if they have problem using or navigating your software, then your technical success is not equal to user success. Okay, so explicit user signals, star ratings. Okay, how are your user rating your software? Are you getting 1 rating, 2 rating, or 5 star? Are you getting thumbs up or thumbs down? Is your software being accepted or rejected? So all these things must be considered before you design a user interface for any software you are designing in general. So implicit user signal, interaction log. So always check your log, always check what your users are saying. Drop-offs, check your drop-offs, check your delays, check all the misinterpretations and misunderstandings, check this user sentiment, check the sentiment of the user. Okay, that's why you see many of these AI, they will put they will send like a feedback form for you to fill and ask whether you are satisfied or you are not satisfied. Like Grok, it will ask you to rate Grok interaction and the response to you. So those are means of getting feedback from your user. So when you are also designing a system for user interface, always put human in the loop validation in your system. Okay, so for high-stake system, human expert must review outputs, must validate correctness, ethic, and compliance. They must use finding to, calibrate, automate evaluation. So there is always, in all these enterprise agents particularly, there is always in human in the loop, where the agent will take 50% action and then the human in the loop validate. So this blends automation with human judgment. So end-to-end and environment testing. So always make sure you do end-to-end testing, do your end-to-end testing, your unit testing, deployment testing, and end-to-end testing. Make sure you test to your backend, test your APIs, and test the front end. Okay, act as a user and see whether the front end actually work, and see and experience what your user will actually experience when they are using the system. So check your data injection, check your tool execution, check your decision logic, and also check your output generation. Are they okay? Are they 100% okay? Will they, with all these things be accepted by your user? So testing is very important when you are developing agentic system. So real world testing, like in production, real world testing like unpredictable user behavior, edge cases, load spike, real failure or failure modes should also be put into consideration, and you must do control tests. Okay, to make sure all these things are taken care of. So while reward testing is essential, so it reveals hidden edge cases. It also reveals test performance under load, and it validates robustness in live condition. So best practices: before you roll out, don't roll out the application at once. Okay, there's what we call in software project management, there's what we call agile methodologies. So roll out gradually, start small, then scale. Okay, so gradually scale until you reach your destination where the system is actually stable. Then reduce blast radius of failure. Okay, do not just roll out everything at once. Roll out gradually and then upgrade later. You can see Claude, when it first came out, or like around was it 2023 or 2024 thereabouts, it wasn't as good as this, but they roll out what they have then, and they started scaling up and designing for enterprise, and you can see where Claude is today, and so it's better than what we have in 2024. So also implement monitoring and continuous feedback. When you implement your log, make sure you read your log, go through your log to know how your system is behaving, and implement continuous feedback. Make sure you design your system to receive feedback and iterate continuously. So continually improve your system and your architecture. Okay. So these are things that you should put into consideration when you are designing agentic system. Okay. So what we want to look at here is actually the practical, not the theoretical one. So let's continue with what we have in our code here. So UX design for agentic system. So the project we'll be looking at here is multi-modal interaction pattern. So how multi-modal agents interact together when they are put together. So building a scalable agent is only half of the work. Okay, like I've said, technical success is not equal to user success. So users need to trust it and feel in control, okay, of it. So this chapter covers the key UX challenges unique to AI agents, and then we'll be looking at the following 4 challenges. So how much should the agent do on its own? Okay, do you want the agent to take 100% autonomy, 70% or 50%? Or do you want it to be 0%? If it is 0%, it is no longer agentic, of course. So to determine how much the agent should do on its own, you must implement what we call autonomy slider. That you must design a slider in percentage to determine the autonomy level of the agent. How to support test, voice, GUI interface, that's modality formatting. To solve that problem, you implement modality formatting. When should the agent explain itself? Okay, this is also very, very important. Very, very important. Okay, so confidence plus reasoning transparency, right? It's what solves this problem. So how to avoid overwhelming new users. So, or to solve that problem, do not overwhelm your new user, as I have said. If not, when they are overwhelmed, they will be discouraged. Okay, you log into a software for the first time, and then you want to do simple thing, and then you are stressed up. So won't you leave that software and go for another one that is easy to navigate, that will give you what you want, in a very short latency of time? So that's how it works. So to solve the problem of overwhelming user, we decide what we call the progressive disclosure. Okay, so before we continue to our first step, which is importing our modules and all we need to use, let's look at the architecture. So look at the architecture here. So we have your user type here, then experience level of the user goes through here. Then if the user is a beginner user, suggested agent suggests what to do to the user. Okay, so if you have an inexperienced user, you should design for the agent to suggest solutions to the user. If your user is a power user, which is very, very experienced, tech savvy, then autonomy level. So autonomy should take place here. Agent acts independently. Agent acts independently. Then for the beginner user, agent suggest and then move to agent act plus human review. So you can implement this for beginner level user. Agent suggests what to do to the human and the agent acts plus human review. So agent can suggest why human acts or agent acts and human review. These are the design that you can design or for a beginner user. If you are building agent for a beginner user, you can follow this pattern. Agent suggests what to do, then the human acts, or supervised. This is suggested. This is supervised. Agent acts, then human review, and then you for power user you have complete autonomy. So human does all. We also have another design where human does everything and still pass on to agent suggest. So this is the architecture of what we want to look at in chapter 3. Okay, so now let's import all our modules. Import type, import JSON. From typing, import list, date, any, optional. From enum, import enum. From data class, import data class. From date time, import date time. And then if we run this using Python 3, I'm going to run that now. Good. So our modules are imported and it has run. And then we have our step 1, the autonomy slider. So the autonomy level is the most important UX control in an agentic system. So always put autonomy level into consideration. Again, put your autonomy level into consideration. So think of your autonomy level as a slider. As we have seen in the architecture, we have manual where the human does everything. We have suggested where agent suggests and human does everything. Where agent suggests and human acts. So we have a supervised, design where agent acts and human review. Agent take the action, human review the action before it is completed, and human submit it to complete it. Then we have complete autonomy. That's no human in the loop here, no human in the loop. Agent act, agent review, and agent perform the complete, agent solve the complete problem 100%. Agent act independently without asking any question. So different users at different times need different position on this slider. So a power user automating workflow wants autonomy, complete autonomy. So for a power user who knows how the agent works, who is not new to the system, we want complete autonomy. Whereas a first-timer user or a beginner user would like to go through the route of suggested or supervised, where the agent acts and human or review. So this is the design we are going to design into the system. We'll follow the architecture as we have seen in the architecture. Human does it all, that's manual. Then we have experience level beginner, suggested, supervised to autonomy. Then we have for power user straight to autonomy. So here, class autonomy level enum. So remember, we are using enum to define all our collections. So create a name collection. So what enum does is to create a name collection of name value pairs, example enumeration. So that's in enumeration, that's create a collection of names in form of, is another way of defining a dictionary, so which is better in this case. So class autonomy level, we have manual, that is graded to 0. We have suggested, that is on slider 1. We have supervised on slider 2. We have autonomy on slider 3. So these are what we have there. Then class modality type, enum, text, GUI, voice, or multi-modal. So these are the kind of control that we can program into our system. And then confidence level, low, medium, high. So it is very important that you put these designs into consideration in agentic UX design. Then user preference and agent response. So user preference is a configuration object the user or the app setting fills in once. Okay, so this is just like a configuration object the user can fill in once, or the app object fill it once. So that is the preference, designing the preference for the user, whether the user is a power user or beginner level user. So they can go for their preference, human control everything, or suggested, supervised, or autonomy. So agent response is a structured response, not just a string, but also metadata the UI layer can act on. So we have a structured response from the agent that the UI can act on. Remember, user preference is what the user or the app setting can fill in. Confidence, show a warning badge if low. Okay, require approval function, block action until user confirm. Alternatives, show a drop down of interpretations, reasoning, toggleable explanation panel. So these are the classes that we are going to define and the functions that are actually under them. So we have class user preference, define your initialize your user preference. So we have the data, we are using data class here, autonomy level, preferred modality, show reasoning, require confirmation, verbosity level, which is 2. Then class agent response, content, confidence, reasoning, alternatives, require approval, and sources. So we have these 2 data class now in our system. Now let's go to step 3, the interaction manager. So this class handles the full life cycle of user interaction. Assess confidence based on query length. So if it is simplified, in production, this is simplified, we are going to use LLM. Generate response with optional reasoning. Apply autonomy control, e.g. force approval at suggested level. Format for modality, test get full reasoning, voice gets a short clean string, GUI also get JSON. Okay, so format for modality, test get full reasoning, voice gets a short clean string, and GUI gets complete JSON. So notice how the same response object flows through shape step and get transformed. So let's see our interaction manager class, and we initialize the class self.preference, self.interaction history, self.pending approval. So this is the class blueprint, and then we define this method that will carry out the following process: process input self, user input string, modality type, map to agent response. So print interaction modality, and the response equals to self.generate response, response equals to self.apply autonomy control, which we have defined above, formatted equals to self.format for modality, and self.interaction equals to .append input modality timestamp, and then return formatted. So this method allows this class to implement all the blueprint, all these autonomy level that we have defined here. And then the next method, assess confidence. So length user dot split. If length is less than 5, return confidence level dot low. If length is less than 15, return confidence level dot medium. You can see how we define the confidence level. Okay, so this is ambiguous short query, so return confidence level high. So you can see the definition. When the length of the user input is less than 5, confidence level is low. If it is greater than 5 and less than 15, confidence level is medium. Otherwise, if it is higher than 15, then it awards high. Then another method, generate response. So confidence equals to self.assess confidence, calling this function. Reasoning none. If self.preference.show reasoning equals to passed whatever user input is, and then alternatives. If confidence equals to confidence level dot low, alternative interpretation A, interpretation B, or user input 20 or otherwise, so that will be high. Return agent response, content processing, user input, confidence equal to confidence, reasoning, alternatives equal to alternatives, requires approval, confidence equals to confidence level dot low. So that is what that one return. Then after that, we define a method to apply the autonomy control. Please follow the sequence. We define the interaction manager class, and we initialize the class with this preference, interaction history, and pending history. We define the method that the class will use, process inputs, assess confidence, generate response, and then apply autonomy level. Okay, apply autonomy level to the what we have. Remember our autonomy level of 0, 1, 2, 3. So 0 is human takes action or the action, or 1 is suggest, the agent suggests, human act on everything, and 2 is supervised, agent acts, human review, and 3 is complete autonomy, agent take complete autonomy. So this method processes the autonomy level, apply the autonomy level to the user query. So level equals to self.preference.autonomy level if level autonomy level, response.content equals to manual, response.query approval equals to true, elif level autonomy level dot suggested, response.content equals to f suggested, response.require approval true, elif autonomy level supervised. You can see how the sequence go, response.confidence, response.content acting, elif if it is complete autonomy, then response will pass to complete autonomy class where we have defined, then it return response. Then format for modality. So modality type, remember we also defined our modality type. So this method apply the modality. If modality equals to modality type dot test, response dot reasoning, and response dot preference dot show reasoning. If response is dot alternative, extra plus alternative dot join enumerate response dot alternative, response dot content equals to extra, elif modality type GUI, response dot content JSON dot DOM GUI. You remember we programmed the GUI to receive JSON. Elif modality equals to voice, then it will return voice. So this is how voice or GUI response, everything is programmed into your AI. You can design it to to speak, to say the response to you verbally instead of writing it. So this one gives you the test in JSON format via GUI in JSON format, and this just gives you the test. This is the normal test we see. This is JSON format, and this is voice format. Okay, and then return response. So let's run this function and see. So this function has run successfully. So we've successfully defined our interaction manager. Now, progressive disclosure. So don't show all features to all users. Okay, remember, you don't show all your features to all your users. You must hide some things that are confidential as well. Beginner get overwhelmed, expert get frustrated by hand holding. So if you show everything at once, then you'll be overwhelming your users. Even though some of them are experts, they may still feel overwhelmed. So progressive disclosure reveal features as the user's expertise grows, keeping the interface clean at every level. So do not just load everything into the interface at the same time. Make sure you implement progressive disclosure. As the platform gets bigger and you get more customer, you may decide to progress by introducing new thing to the GUI, but do not just program everything at the same time. Okay, just roll out or use agile methodology. Okay, so class progressive disclosure, self.user expertise, beginner, self.show feature, self.feature. We have beginner. Beginner will see basic command, help examples. Intermediate users, basic command, help example, shortcut, customization. And expert users, basic command, help example, shortcut, customization, advanced tool, and API access. So this is our progressive disclosure. You can see the step that they follow. So they get features to show self, return self.feature.get, user expertise self.feature beginner. So I'm going to run this query now, and then we have that in the system. So demo autonomy level in action. So let's demo everything we have done. So for autonomy in autonomy level, let's print out all that we have programmed above. Pref, user preference, manager, that's interaction manager class, and then we have all this. So let's run this and then look at what we have defined above. Our autonomy level is manual, user needs help, interaction modality test, autonomy manual. So human is taking action here. Agent mode, please provide instruction. Agent mode, the manual mode the agent will show is please provide instruction. You can see how to program it. Reasoning past, help, confident intent, retrieve contents, formulate, awaiting user approval. So user will put in please analyze the quarterly financial report and provide insight. Interaction modality test, autonomy manual, agent is in manual mode, please provide instruction. So reasoning pass, please analyze the quarterly financial report and ID, awaiting user approval. You can see how the workflow will go if you are using manual. Then if you are using the suggested autonomy level, it continues that way. Interaction modality test, autonomy, autonomous. So agent autonomous processing, please analyze the quarterly financial report and provide insight. So or reasoning past, please. So it's just continuous like that. If you want to see more, you can we can expand this to see more, and we'll have enough of that. Okay, so it continues like that. It continues like that. It continues. So we have used the first one as an example, and then this is the autonomous level. This is the output. This is the supervised. You can say supervised or agent acts, and this is the acting. Please analyze the quarterly financial report and provide insight. Then human will react. Then this is complete autonomy. The question is asked, please analyze the quarterly financial report and provide insight. Then agent act autonomously on what is passed and just give you response. So print same query, 3 output format. So let's see the output of everything that we have run above. Same query, 3 output: interaction modality test, autonomy supervised. You have the reasoning, show me the latest updates, identified, retrieve, formulated response. So see the GUI format, see the GUI interaction, how it will be printed out, and voice modality voice, autonomy supervised. I will processing, show me the latest test. So this is the voice part, this is GUI, and this is the test. Okay, and then progressive disclosure by expertise level. So let's see how our progressive disclosure work. Progressive disclosure by expertise level. Beginner, look at what we program for beginner. Intermediate, we have intermediate. Expert level, we have expert. So this is how you design your GUI or for user interaction, and these are what you can see. So when you are building your agent, put this into practice. It will help you attract users a lot, and it will help whoever you are developing for to also be able to navigate the system with ease. So in summary, we have looked at how to design GUI interface, or how to design GUI interface or UX for agentic system to make it user friendly. Designing for different users, you must put different users into consideration. Put beginners into consideration, put the intermediate level users into consideration, put the expert also into consideration. Design for all users. Do not just design for specific niche of user, design for all users so you can have more customers. So concept and implementation. Autonomy slider, autonomy level, apply autonomy controls. Okay, structured response, agent response data class. Multi-modal formatting, we use format for modality function. Confidence based approval, we use this function access confidence plus require approval. Progressive disclosure, that's showing little by little, not just everything by once. Show things to the user based on their level, beginner, intermediate, or expert. So we use this class progressive disclosure to implement that. So what have you taken, or what have you learned from this lesson? So the key insight. So we've looked at some underlying agent logic, and we've seen that they produce very different user experiences depending on autonomy level and modality. So UX is a first-class concern in agentic system design. So it is a first-class concern. Put it into consideration and remember that technology success is not equal to user success. So to make your technology your user success, make sure you design UX for your user. Design UX to be easy for your user and make your UX design, a first-class concern in a agentic system, and always perform end-to-end testing. Okay, so let's run through our complete application. So this is all our code as we have defined in the notebook. This is the complete workflow, and then if we run this now, we see everything. It's run without problem, and then we see our output. Okay, so this is how the backend will look like. And then this is just a practice, this is a lesson. And if we are connecting or building in production, so we are going to connect your Claude API like this, or replace generate response with Claude output, and then add Anthropic API key. Remember, I've shown you this before. You can add your Anthropic key here. If you are using API, add it here. If you are using other ones, you can just add them in their format. Okay, so and then we have to import the following: cs pathlib config, and get. We have to call the Anthropic client goes to get Anthropic client, print Claude client. So but we don't have API key here, so we are not going to run this. And then we are going to redefine the interaction manager with Claude now, not just ordinarily. So uses Claude to generate real responses instead of simulated one. Generate response self, user input, agent response. So confidence self does access confidence is self.preference.show reasoning. System prompt, briefly explain your reasoning before your answer. Response equals to client message.create. Claude IQ, we are using Claude IQ here. Max token 300. System prompt, and we have our message. Okay, remember your max token is the amount, is the length, of text that the API should give you as an output. The more the higher your token is, the higher your cost is going to be. So we are going to put it at 300. Then content equals to response.content, return agent response. Content equals to content, confidence equals to confidence, requires approval equals to confidence, assigned to confidence equals to confidence level dot low. So and then prefs, user preference. This one apply the user preference supervised, that's agent act human review. Manager level, interaction manager with Claude. So using this class that we have defined here, response equals to manager live.process input. What is the react pattern in AI agent? So if we have put our API key here, now we are going to see the real life action from Claude IQ, the answer directly from Claude IQ, not hot-coded. So this is how it works, guys. So this is the end of this chapter 3. I hope you have learned a lot, and remember to like this channel and subscribe, and tell someone to also tell someone to also tell someone. Okay, so thank you very much. See you in the next class. Bye.